Hello, we are here for one more lesson of this SprutCAM training course, and the topic for today will be the 5-axis machining. We've seen previously the 4-axis machining, and some examples we've seen had the intention to show you that the kinematics of 4-axis machine can be a little different from what we have on the conventional 3-axis. Even so, when we move from 4-axis to 5-axis, then we can have a very different configuration and very different settings of machines. So again, it's crucial to have the proper kinematics defined. Okay, and we will see that configuration of robots, because we can have also a robot doing the machining even with more axes than only the 5-axis. But again, we will see the configuration of this kind of equipment, and then when we have everything correctly defined, we can have a little different programs where the collision control should be very accurate, and we must be extra careful with all of this, because having more moving parts on the machine volume area, it is dangerous for the machine, for the part. I would say not for the people, because usually it's a closed area, but it's something where we must be extra careful. So the idea today it is to show you a couple of different options we can get under this 5-axis machining. I start with this example, a very simple example. We have a part. This is a 5-axis machine where this rotating table has movements. And we have this small pocket with this pentagonal shape, where we created a simple 3-axis machining, as you can see. So one very interesting function we have is the possibility to convert these 3-axis to 5-axis. So if I simply click on the program, we have an option under strategy that says 5-axis conversion, activate. And then we have a couple of parameters. We can change the possibility on how the program is affected in terms of behavior. Okay, I will leave it through point and recalculate this, and we will see the difference. So now, because we have the proper kinematics on the equipment, I will slow down this a little. And now, as you can see, the machine moves and the z-axis is always fixed. Okay, very clever, I think, very easy, very interesting stuff. Another example we can see, it is this advanced example, where we have a couple of programs. Okay, let us open this. We've done also a simple roughing water line, which I will delete. I don't care about this. And we will machine this area, because it has a shape. This defining area, this radius, is not flat, so it is useful, and we will achieve a good quality if we machine only under these two areas. So how do you do it? One of the tricks, it is in job assignment. We choose, as you see, the surface, okay, and then first curve, second curve. So basically, it's evolution from this curve to the second curve. It's very simple. And in terms of parameters, so we have this strategy called morph between two curves. We could do other things, okay. But I think it's quite nice, this one. We could, for example, okay, mill mode, we can do both ways, no problem. but we can do, for example, the parallel. I would not a cross curve. To orientation also we can leave it. We can try to we can try to do something a little different, which is okay, this one from outside in, for example, doing this a little different, and let us see what happens. Okay, we have the same program, this time maybe a little different. We don't have the roughing, so it will feel a little strange, and we have this kind of behavior on the tool. It could be other thing we could do. Instead of going following the curves, you could do it across. So it's another idea to make the program. Another interesting possibility, doing also a curve. It's 5D contouring. The same equipment we've seen on the first video. This one, being a contouring, basically follows a curve. And again, what is important in this particular case, it is a job assignment. In fact, job assignment is one of the most important parameters we can get. So job assignment, if we choose, for example, a couple of curves, let us define this, not all around, but these ones I think are enough. Edge curve on surface. He found already a couple of parameters based on the curves and according to what we have defined under the parameters. So entries, parameters, so on. I will not go around this because we've seen a lot of these in all the videos. Sorry, we need to calculate it. And okay, he positions himself to mill that curve. Let us try to simulate this slowly and see what happened. As you can see, very nice program, very smooth, and with the proper kinematics, everything is done without collisions and without problems. Another example, for example, this kind of part, also very interesting, applying the 5-axis. Let's open the machining. So this is a part with a very narrow area here. This is always the same stuff, where the important part it is the job assignment. Okay, we have the kinematics defined. The tool it is defined as being able to do a program in 5-axis. So all of these parameters, you know them already. And then for this first one, the others are similar. Job assignment. Okay, we simply have machining surface, this surface in blue, going from this curve to this curve, and simply go and do it. Okay, and what happens, it is, let's try to see it a little behind and then approach it. I will move this a little more faster. And as you can see, the table is it's a little tilted, and it will go moving to avoid the collision. Okay, and this program moves under this direction, but if we go on the parameters somewhere, so we have the along, we could do a spiral, but I want now an across, and I will calculate it again. Okay, this time, okay, a little different. Let us reset our model, and now it is more visible that the table is tilting to make this. Okay. Regarding the other programs, sorry, I'm a little cold. Regarding the other programs, it's basically the same concept: a machining surface as base, and then from one curve to the other curve to make an evolution. And let us calculate this. As you can see, there's a very nice and very clean program. Let us try to simulate that one. Okay. And okay, it will rotate to avoid collision, and very soft. Okay. Again, there is an option, as you might imagine. For example, on the across, we can try also the spiral. Now this is the other direction, and okay, tilting a little more, and just to try also the spiral, which it is very similar to the other, but it makes a smoother movement. So okay, more smooth than the first one. Okay, very clean also. So these are some ideas to make 5-axis programs. This is not very complex in terms of the definition, because I think the main work is on the definition of the equipment, the call it kinematics. And then in terms of parts, if you can work under 3 axes, okay, it's easier. Almost everybody knows quite well this 3 axis idea, but sometimes in some areas for very specific things, in most of the times, then you can apply the 5 axis ideas and concepts on those very particular items. But I think there is, in most of the times, there is no need to take it more complex and do everything in 5x, because most of the times there is no need for it. I hope these ideas and concepts will help you going into the 5-axis. You can try to create a couple of programs with these first topics. Watch the other videos we have still in this course, because it will complement these things we are seeing now. And among them, we will have also a little about the configuration of robots, the configuration of equipments. So I think it is important to help you entering this. Any help, any support you may need, let us know. We are here to give you all the support and all the things you may need.